So let us now look at the proof of case B. So case B was if M1 and M2 are real and distinct and are of opposite signs, then the critical point 0, 0 is the saddle point. So let us look at the proof for this, and now let us assume that, so since they are of opposite signs, so let me take M1 less than 0, less than M2, so M1 is negative and M2 is positive. Then in this case the general solution will be x equal to C1 A1 to M1t plus C2 A2 e raised to into t, and y is equal to C1 B1 e raised to M1t plus C2 B2 e raised to M2. Again, we have seen this following cases. The first one was C1 equal to 0 and C2 not equal to 0. So when C1 is equal to 0, so we will be getting x equal to C2 A2 e raised to M2t, and y equal to C2 B2 e raised to M2t. So that implies y by x will be equal to B2 by A2. So this will be half lines which is passing through the origin. ഇനി ഇവിടുത്തെ പ്രത്യേകത ഇതാണ്. ഇനി C2 can be either greater than 0 or less than 0. So it will be tracing two half lanes. One will be on the positive side and one will be corresponding to the negative value of C2. C2 in the positive and negative value in position. So we will be getting two half lanes. So that will be giving us a line which passes through the origin. So that is the case when you have C1 equal to 0 and C2 not equal to 0, and when you have C1 not equal to 0 and C2 equal to 0, so again x will be equal to C1 A1 e raised to M1t, and y will be C1 B1 e raised to M1t. So this will be giving y by x equal to B1 by A1. As you can see, these are also lines which pass through the origin, and when C1 is not equal to 0, that means C1 can be either positive or negative. So when C1 is positive, so both these values will be positive and both will be negative this case. So this will be a line which is passing through the origin. Now as we know, we have M1 less than 0 less than M2, and now here when you take the case for M1, so suppose you have this be the line y by x equal to B1 by A1. So as t tends to infinity, since M1 is negative, so this will be approaching to 0. So this will be the direction of this line. Now when you take this line y by x equal to B2 by A2, we can see that M2 is positive. ഇപ്പോൾ നമ്മൾ first case A ചെയ്താണ് നമുക്ക് ഇങ്ങനെ തന്നെയാണ് ലൈൻസ് വരുന്നത്. Now the only difference is since M2 is greater than 0, so as t approaches to infinity, this goes to infinity. Now when t goes to minus infinity, this will be tending to 0. So that they approaching 0. So here if this is the line, say y by x equal to, it is passing through the origin, B2 by A2, then this will be going in the outward direction. So our direction is just because one is positive and one is negative. So as t tends to infinity, this will be going outward, and as t tends to minus infinity, it will be approaching to the origin. And Again, then you have C1 not equal to 0 and C2 not equal to 0. So in that case, so we get y by x equal to C1 B1 e raised to N1t plus C2 B2 e raised to N2t, and we will be getting C1 A1 e raised to N1t plus C2 B2 e raised to N2t. So as you can see, this will represent a curved path. So since C1 and C2 both are not equal to 0, so this represents a curved path. ഇനി നമ്മൾ previous case ചെയ്തപ്പോൾ here you are getting in the form y by x എടുക്കുമ്പോൾ നമുക്ക് ഈ ഫോമിലാണ് വരുന്നത്. Now depending on this difference, whether this is positive or negative, you will get as t tends to infinity, this ratio will approach to either b2 by a2 അല്ലെങ്കിൽ b1 by a1. So that depends on the sign of this. So നമുക്ക് y by x asymptotically b2 by a2 അല്ലെങ്കിൽ b1 by a1 ആയിരിക്കും. So y as t tends to infinity, y by x will be approaching a2 by b2 or b1 by a1. So what happened here is when you have c1 not equal to 0 and c2 not equal to 0, we will be getting curved paths such that they are asymptotic to these lines. So since here t tends to infinity or t tends to minus infinity, the slope can be both b2 by a2 or b1 by a1. So here we will be getting paths like this. So they will be asymptotic to both the lines. So at different values of c1 and c2, the slopes will be approaching to either b2 by a2 or b1 by a1. So hence this will form a saddle point. So hence we are getting two half lines. Then the half lines will pass through the origin. So we are getting two lines which pass through the origin, and the remaining will be representing curves similar to hyperbola, such that they are asymptotic to these lines. Hence, when you have roots where they have opposite signs, so they are real distinct and have opposite signs. So in that case, we will be getting a saddle point. So this gives the proof for the origin to become a saddle point.